Now the question here comes, okay, we understood what is the probabilistic picture of an atom. We understood it. Now we understood also that yes, with certainty we cannot say the position of an electron, so hence we need to go to probabilistic picture. We need to have another theory, that is modern atomic theory. We understood what is electron cloud in terms of dots, we have understood it. Now the next question comes, a very important question, it can be asked by you, that sir, why did the previous theory, all other theories failed? Only one reason, only one point. Because they did not consider the dual nature of electron. Alright, they did not consider the dual nature of electron, that is both particle nature as well as wave nature. They did not consider. They either considered the particle nature or they considered the wave nature, but they did not consider the dual nature of electron. For that particular purpose, that is right from Thomson to Rutherford to Needworth, everybody failed in their concept. So hence the dual nature of electron was considered by de Broglie and Heisenberg, and hence they raised the question upon what you can say Bohr's atomic model. For that particular, because their concept, if you see, is based upon the dual nature of electron. So that is just in one word we can sum up that they failed the classical mechanics, the classical theory, it fails because they did not consider the dual nature of electron in an atom. Alright, so when you consider the dual nature, that's the wave nature as well as the particle nature. Now considering the wave nature, here Schrödinger, another scientist, that is known as Schrödinger wave equation, we can say that. He told us that is when an electron is moving, it describes a wave. Listen carefully, it describes a wave. It can move in any path. So it can have innumerable waves. Number of waves it can have. Now waves has got no significance here. And he represented the wave by a function that is called as, this is known as psi. This is called as psi, pxi. It is spelled as psi. This is psi represents what? Wave function. Wave function means, let us say, the amplitude of the wave. Amplitude gives us what? Intensity. Intensity of what? Intensity of sound, if it is a sound wave. Intensity of light, if it is a light wave. Intensity of electromagnetic waves, or electrical and magnetic field, we can say that. So it gives us intensity. Amplitude gives us, isn't it? You have read it, what is intensity. So hence psi has got no physical significance here. Alright, the amplitude of the wave has got no physical significance here. But if you take the psi square, the intensity square, then it has got some physical significance. According to Heisenberg, it is nothing but the uncertainty in position. That is the probabilistic picture it becomes. When you take the psi square, alright, listen carefully. When you take the psi square, then it is the, according to Heisenberg, uncertainty principle means the probability of finding an electron at that point. The probability of finding of electron at that point, according to Heisenberg, when you take the psi square, when you take the intensity square. Otherwise, intensity has got no physical significance here, in this particular theory, in the modern atomic theory. It may have physical significance in electromagnetic wave theory. I am not talking about that. Try to understand. I am talking about the modern atomic theory. We have to find the position of the electron. So hence psi has got no physical significance. It has got, according to Heisenberg's, it has got a physical significance when you take the psi square, we can say, which was said by Schrödinger, we can say that, Schrödinger, another scientist. So, what it has said, the psi square at any point gives the probability of finding of electron at that point. Psi square, what I said you, it gives a, according to Heisenberg, it gives a probabilistic picture. That is the probability of finding of electron at that point. That is density of the electron cloud at that point. It gives us. Alright? Density of the electron cloud at that particular point, we can say that. Now, next is a particular atom, a particular electron has innumerable, I said you, that is wave function it may have. Alright? Since an electron can have many wave functions, therefore there are many atomic orbitals in an atom. Now, where this orbitals came? The probabilistic picture of an atom describes that, again I repeat, the density or the probability of finding an electron is maximum, but the density of the electron cloud is highest. You know what then gave the name of this particular, this one sentence in one word, what you can say is that known as orbital. The psi square is that particular one. So the symbol is psi square, but in one word what we can sum up? Orbital. So what is orbital? Atomic orbital is defined as a three-dimensional space around the nucleus within which the probability of finding an electron of given energy is maximum. I said you already. That electron cloud where the density is maximum, there you can find the maximum number of electron. So what is that? That was said by Schrodinger as psi square. Psi is the wave function. So Heisenberg's, he did it further. He told us further that psi square represents the probabilistic picture of an electron in an atom where the density of the electron cloud is highest. So what is that in one word we can say? That is nothing but known as an atomic orbital. So hence I say that an electron can have in many wave functions because it can have many waves. It's not one wave it is having. It can have many different types of waves. So hence it can have many different types of what you can say psi square. Got it? That is psi square is nothing but what? Atomic orbital. So as electron can have many wave function, there can be also many orbitals present in an atom. So the orbital wave function psi contains all the information about the electron in an atom, and quantum mechanics helps us to derive that particular what you can say information. Alright, atomic orbitals gives us all the information about an electron in an atom. All information means you will come to know in quantum what you can say mechanics. In the quantum numbers you will study all the information. But have you understood what is atomic orbital? Again I repeat, atomic orbital may be defined as a three-dimensional space around the nucleus where the probability of finding an electron is maximum. Right from the beginning I was saying in the modern atomic theory the probability of finding an electron. So what is that? That is otherwise known as an atomic orbital. So in simple words I can explain you that suppose we are having, which you will study in the quantum mechanics, you will be studying it in the quantum numbers. Let us say this is a nucleus. Around the nucleus we are having the shells which was said by Niels Bohr. We don't disagree that. We will consider it as. So shells we are having. Got it? Now inside the cells there are finer spectral lines which I have studied, which was said by Zeeman and Stark. The finer spectral lines was considered to be as nothing but known as, that is subshells. Mind it. Nucleus, shells. Inside the shells we are having the subshells. Got it? Clear? Inside the subshells we are having the orbitals, because if you take the detailed picture of an atom, then you will reach the, that is the smallest part, that is nothing but the orbitals where the probability of finding an electron is maximum. So that is known as an orbital. Alright, that is called as an orbital. Again I repeat, we are having the nucleus, we are having the shells. If I show you a picture, then you can get this particular picture, that where the orbital is situated. That this is a nucleus, around the nucleus we are having the number of shells we are having. Got it? Inside the shells we are having number of subshells are there, which you are going to study in the quantum number. I will teach you the different quantum numbers. You will see the shells is known as principal quantum number. I will tell you. The subshells are known as azimuthal quantum number. I will tell you. Got it? Then inside the subshells we are having the orbitals, which is nothing but known as your, that is magnetic quantum numbers. I will say you. And one more quantum number is there, that the electron is spinning. It is not at rest. When the electrons is present in the shell, subshells or orbitals, not at rest, it is spinning on its orbit as well as it is revolving in its path. Got it? So hence it has got a spin. So what type of spin you will be studying in the spin quantum number? That is the quantum numbers which you are going to study now. So these gave rise to quantum mechanics. So hence what I said you, when you will study about the atomic orbitals, you will be studying about the quantum mechanics, you will be studying about the quantum numbers, and you will come to know details about it. Got it? So these gave us, just you see from where we started and from where we have come. We started from, that is, discovery of electrons, protons, neutrons, then Thomson's model, Rutherford's model, Bohr's model. In between we have electromagnetic wave theory, Planck's quantum theory, which gave rise to the Bohr's atomic model. Then after that, the Bohr's atomic model was challenged by Heisenberg and de Broglie. Then we came to the Schrodinger equation, the modern atomic theory, from where we studied the probabilistic picture of an atom, and from there the probabilistic picture of an atom describes an orbital, and from that orbital we came to know about the nothing but the quantum numbers, we can say that. So got it? So more about it we are going to study in the next TV. I hope you understood that it's going to be more interesting. Thank you very much.